All right, we want to sketch a graph of the exponential equation y equals 2 times 2 to the x. So let's take a look at some important points on this graph first. Let's find the y-intercept of the graph. The y-intercept is what is the value of y when x equals 0. If x equals 0 in this case, that would make this 2 over here equal to 1, and then we're left with just the initial value 2. So when x equals 0, our exponential graph crosses the y-axis at 2. We can also see, since the rate of change, the base of the exponent is 2, that means for every unit of x that increases, this function grows or doubles. This is an upward sloping graph because it's exponential growth, so we know that the shape of the graph is going to be something like this. It's going to curve upwards. And the other thing that we can see, if x gets really negative, no matter how negative x gets, this value 2 is never quite going to go away. It's going to get smaller and smaller and smaller, but it's never going to get negative because there's no negative numbers involved in here. Let's say x were, this were 2 to the negative, or sorry, 2 times 2 to the negative 10. This turns into a fraction, right? 2 to the 10th. And it becomes 2 over 2 to the 10th, which is just a really small number that gets really close to 0, but doesn't actually cross 0. So we've got an upward growing graph, and as x gets really close to, or into really large negative numbers, the graph just gets closer and closer to 0, and it goes through this point 0, 2. So we can sketch an approximation of what this graph is going to look like, and it'll probably look something like that. If we want to make it even more accurate, we should test out a second point in this positive area over here to see where to connect the graph after it goes through the y-intercept. And so if we plug in what's the value of y when x equals 2, 2 times 2 squared equals 8. So at 2, y actually equals 8. And we can see the first graph that I drew was not so accurate. I can adjust this graph, and it's growing even faster going up that way. And there is an approximate sketch of y equals 2 times 2 to the x, my exponential equation. Let's try another one. Here we have a decay factor of 1/2. So our amount is getting smaller and smaller as x gets larger and larger, it grows more and more positive. What would be happening to this graph if x got really negative in that direction? Well, 1/2 to a really large negative number, let's say like 10 or something, would cause this to flip over and turn into 2 to the 10th. Which is like multiplying 6 by some really large number. So as x goes negative, this graph goes really high up. As x grows in the positive direction, this graph gets lower and lower. So the shape of this graph is going to look something like this. Now we can see again that this value will never actually reach negative number. It will always stay positive. And let's see what our initial value is when x equals 0. If x equals 0, that gives us y equals 6 times 1/2 to the 0 is 1. So y equals 6. That's our initial value of this function. And let's test out another point to connect our initial y-intercept to. Let's test this out for x equals 2, which will give us y equals 6 to the 1/2 squared, which equals 6 to the 1/4. And 6 over 4 is equal to 3 over 2, which equals 1.5. So when x equals 2, y equals 1.5. And we have a downward sloping graph that goes through 0, 6, and 2, 1.5. So when we are graphing exponential functions, we want to look and see which direction is the graph sloping. Is it an exponential growth or an exponential decay graph? Growth will usually look like that. Decay will usually look like this. and we want to find a couple of values, the initial value or the y-intercept, and some other point to connect those points together.